Hey all, we are taking a look at erythrocytes, red blood cells, what normal ones look like and what irregular ones look like, ones in different forms of anemia. Anemia is a set of many different possible conditions where there could be something wrong with the red blood cells or you have low amounts of red blood cells, basically leading to low blood oxygen. Okay, here we're looking at a regular blood smear. These are normal erythrocytes. We know they're normal because we can see the nice roundish shape. Like, it's best to look at ones that are on their own. Nice roundish shape. You look at the outer edges of the erythrocyte. It's darker red. The middle is lighter because of the biconcave shape of these cells. We are at 1000x. We're at the oil immersion lens, 1000x total magnification. That's what a normal erythrocyte looks like. Let's take a look at an irregular one. Let's start with a classic one. Hopefully you can tell what it is by looking at it. Let's see if I can get it in focus immediately. There we go. Almost. Work on the contrast and lighting here. Great. Okay. Here we're looking at cells, and immediately we can see something's wrong because look at the center. It's dark. If the center's dark, that means the cell is misshapen. So when we look at this view, at this flat view, we can see that the cell is misshapen. Excuse the debris here. Ooh, that oil's getting all weird. Okay, so we can see that cells are misshapen because it's darker in the middle. What we can also notice in other cells is that some are kind of pointy. Like, not all of them are round. Like this one that I'm pointing at here, it kind of has a point to it. Let me find another good example. Here, this one. This one is pointy. This one here is pointy. Another good example. I'm trying to find the classic example of this condition. See if you've guessed it by now. Over here, very, very long and pointy. This one right here. And here's another good one. Kind of looks like a half crescent right here. I'm going to move it to the right. Yeah, kind of looks like a crescent. This is sickle-cell anemia. This slide is of sickle-cell anemia. The cells are misshapen. They're sickled because of a mutation in hemoglobin. And if you have misshapen cells and your spleen interprets these as damaged and you start destroying these at a high rate, also this has potential to clog up capillaries, which of course is never a good thing. This is sickle cell anemia. The cells are sickle shaped. I know it doesn't always look sickle shaped, but the cells are in odd shape. Some look very sickled, some just look odd and misshapen and pointy. If you see pointy cells that aren't dimpled, you're looking at sickle cell anemia. All right, switching to a different slide. Let's go with this type of anemia. Again, we're going to stick to 1000x oil immersion. Let me get it ready. That oil settle in. There we go. Okay. So in this slide, we can see, it's easiest if we see the ones that are out on their own. I don't know if you can remember what the shape of a normal red blood cell was, but it was obviously round, but I mean the size of it. The cell here the erythrocyte that you see here that I'm pointing at, it is roundish, sure. Oh, that oil's traveling. Hold on. There we go. It is roundish, but look closely. The cell is a little bit smaller, and the white space is a little bit bigger than normal. These cells are a little bit smaller, and the white space in the middle is bigger than normal. The term for this is since it's smaller, it's microcytic, and because of it has a larger white space, it's hypochromic. Microcytic, hypochromic. That's what these cells are called, these erythrocytes. Microcytic, hypochromic. What makes a cell smaller than normal? One thing that can commonly lead to this is these ones are especially small. So these are good examples over here. Iron deficiency. Iron deficiency can lead to microcytic hypochromic anemia. So this is an example of that, microcytic hypochromic anemia because of iron deficiency. When you lack iron, you're not able to produce hemoglobin, the protein that you need for carrying oxygen as much. You're not going to be able to produce high amounts of it, and that leads to smaller cell size. Microcytic hypochromic anemia due to iron deficiency. One more type of anemia that I'd like to show you. This one is also because of a deficiency, because of a vitamin B deficiency, B12, I believe, if I'm not mistaken. Again, we're going to go to 1000x. Let me center it. Let the oil settle in too. There we go. Perfect. Okay. What you'll notice is that the cells are a bit misshapen too, but let's look on a cell that's on its own. We're at 1000x. We can see a cell here, like this one right here. It is lighter in the middle. It is darker on the outside. Hopefully you can tell that it's bigger than normal. It tends to be more oblong. It tends to be more oval shaped. The opposite of microcytic is macrocytic. So these are macrocytic and still hypochromic because it's very light in the middle. Macrocytic hypochromic anemia. This is caused by a vitamin B12 deficiency. How can that happen? That can happen because of either you don't get enough in your diet, like leafy greens, for instance, or you have an autoimmune condition that prevents you from absorbing the nutrient. It's also known as pernicious anemia, Pernicious, but we'll call it macrocytic hypochromic anemia due to an inability to absorb or a low amount of vitamin B12 in your diet. So those are 3 types of anemia I'd like you to know and be able to identify under the microscope. This is macrocytic hypochromic. We saw microcytic hypochromic due to iron deficiency, and sickle-cell anemia, which I don't know if I mentioned, is a genetic condition, so you can't just get it from somebody unless they're your parent. All right, that's all for the anemias. Thanks for listening. Let me know if you have any questions. Take care.